if on the addition reaction, what we have is breaking one of the double or one of the triple or even two of the triple bonds between the carbon. And then as a result, we have one product. In the substitution is we are substituting one of the hydrogens or the halides with something else, usually an halide or hydroxide, so 3 types. And then in the elimination, what we will see is that an alcohol will react, of course, in the presence of a very strong acid as a catalyst, which is present there, but it is not doing anything. You know the function of a catalyst to produce an alkene, double bonded, and water. Now, always, this is like just starting now, always you have when you are standing at one of the carbons. So let's suppose that we have this butan 2-OL. So it's an alcohol. The structural formula of it will be something like this. Since we have but, then we have 4. Since it is butan 2-ol, then what at the second one, at the second carbon, we have OH. And then on the other ones, we have hydrogen. So hydrogen, hydrogen, hydrogen. Okay. Are we good with the structure here? Now, as the elimination, what it is doing, it is saying that those two that are close to each other will be as a separate entity. And HOH is nothing but water. HOH. Okay? So, and then those two bonds that now are becoming quote unquote free, that what they are doing is they are forming a double bond here. So this is why when an alcohol reacts with the presence, so just is present, but it's nothing on it, okay, with the presence of a strong acid. This is why you see only one reactant in this case. So you may have here a strong acid as sulfuric acid, okay? React with it to produce an alkane. Means double bonded. And HOH, which is nothing but water. So now, the question that you may have is, you will say, why is this OH bonded with this hydrogen to form double bonded here? Because what you are doing here is water and but 2 N, which is structurally is carbon, 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 and then you have hydrogen, 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 hydrogen. Okay, so why, you may ask legit question, why is it with this carbon here, carbon between 2 and 3, forming the double bond and not between 1 and 2? Because you will form this double bond with the carbon that has more carbon to carbon bonds. So what am I saying here? Let's take a look at the butan 2-ol. Okay. So we have C, 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 and then here we have OH, and then everywhere else we have H's. Now, this is carbon number 1, carbon number 2, carbon number 3, carbon number 4, okay? This OH has the opportunity to go either with this hydrogen here or with this hydrogen here. Or with this hydrogen here. Now you have to see with which one is it going. We said that we'll go with the one that has more carbon-to-carbon bonds. So let's take a look at the carbon 1. It has one bond as a carbon-to-carbon, okay, between 1 and 2. And then let's see carbon 3. Carbon 3 has one with 2 and 3 and one with 3 and 4. So carbon 3 has more carbon-to-carbon bonds than carbon 1 that has only one carbon-to-carbon bond. This is why when we are going with this hydrogen here, with this combination here, and the bonds that are free are becoming double bond between carbon 2 and carbon 3, and not between carbon 1 and carbon 2. Okay, makes sense, guys?
With your answer, right? If you're talking about, let's just say you want for that.
The second type of elimination reaction that you will see on chemistry 30 is when an alkyl halide, okay, so an organic halide is reacting with a strong base to form in the presence of the ethanol, okay? So to form just an alkane. So if we have something like this, C, C, and then we have H, 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 and then here we have Br, is reacting with a strong base. So let's suppose that we have a strong base as Na in the presence of ethanol. So OCH2CH3. This being in aqua solution, what we will have actually is Na plus and OCH2CH3 minus. H3 minus. And then what it is forming here, so this, it is kind of replaced, okay, with the hydrogen.
That's what I mean. Okay, that's what we're referring to.
Okay. So we'll have C, C, H, 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 H. We'll have an acid, C, H, O, C, H2, C, H3, and a salt. Okay. The last type of reaction that we will see is the esterification. So we saw that when ester is formed, when a carboxyl acid is reacting with an alcohol to produce ester, okay? As an additional product will be water as well. So when we are talking esterification, it's the same thing as producing ester. We saw that an ester is as a result of a carboxyl acid that in reacting with an alcohol, and then we even said on how to name the ester on the other lessons of organic chemistry, but as a product, it's an ester and water. So I will say here that carboxylic acid is reacting with an alcohol to produce an ester, which now we know how it is named, and water, which you can write it as HOH. Let's see the mechanism in which this reaction is happening. Okay, let's suppose that we have ethanoic acid. So ethan means 2 carbons, and the carboxyl acid has a double bonded oxygen and a single bonded OH. So ethanoic acid. Okay, it's reacting with an alcohol. Let's suppose that the alcohol that we are dealing with is a methanol. Okay, methanol, so methan plus methanol. Methanol, and then as a structural formula of the methanol, we have HOH here, or OHH, doesn't really matter, 1 carbon, and then we have 3, 1 carbon because it's meth, and then 3. Okay, so now see what is happening here. So this hydrogen is kind of pushing over, combined with the OH. And as a result of this, what we have is HOH, or water. Okay, and now see now what we have. What do we have is that we have an O that is, let's say, free, that and a bond here but is available because this OH is taken by H to form water. So those two are saying that, okay, you are free, I am available, let's bond together. And then what they are forming is methyl ethanoate, okay? Because we always start with methyl as the alcohol part, and then methanoate. So structurally, in the structure form, what we will have is something like this. When we have C double bond O, and then a single bond O, that is from here, and then we have a C H H H H, and then here we will have another H's. So in terms of naming, we said that as the tip that we were using, we'll find where the oxygen single bond is, and then the part that has the double bond oxygen is acid. The part that doesn't is the alcohol. Always what we start with alcohol, because alcohol is important to have in a party, and we'll name it as a brunch. So we have 1 carbon, means that we will have a methyl, because 1 carbon means meth, and as a brunch add YL, and then the acid has 2, so ethane, we drop the E and we say OATE. So methyl ethanoate is the alcohol that is formed here. Make sense? As the esterification. not as alcohol. It's the ester that is formed, not the alcohol. Make sense? The last kind of reaction, but is not quite a reaction per se, is that when we have a base, like a monomer, one organic hydrocarbon compound, that it is combined with the same thing over and over again. This process in which one compound is bonded with the same compound over and over again, a lot of times this process is called polymerization. I think, yeah, polymerization. So you have one block, let's say, and this is called as a monomer. Meaning mono means one, so one block that is combined with the same monomer and the same and the same and the same and the same. And what do you see on this case is poly of that mer, poly of that block. Poly means plenty, a lot, or more than one. The way that we name those polymerizations or polymers is just by adding the word poly and then the base of the mer, the base or the name of the base. Okay, so if we have, let's suppose, a chloroethane. Okay, so chloroethane is CH, and then we have CH2, and here we have a Cl. This is the mer, this is the block. When we are naming this, we just say that this as a one molecule is chloroethane. And when we have more than, we name it as a polychloroethane. What do we do, or how we represent it that we have it into is like one is connected with the other, and then the first one is connected with the second one with the third one, and so on and so forth. So you have something like this, CH2, and then CHCl, and then this is connected with CH2 and CHCl, and then this is CH2, and then we have CHCl, and you have this line here and line here at the beginning and at the end, showing that it is continued to connect with the other blocks of the same. And then you have an N here indicating that you have plenty. Okay, so the use of the polymers is it's very common even in our everyday life. We see polymers almost everywhere. Polystyrene is a polymer. Everything, like polymers are very, very used into our everyday life. You can just say only the base or the mer, and then have the two lines here, and then have an N at the end, indicating that you have more than one of this. And then you say, you name it as a poly of whatever is the mer, the monomer, the base, the block that you are building it on. So imagine it like this, that you have a block, and then this block is connected, is bonded with the same block on every direction. Everywhere where you see a possibility to connect, then it is connected, creating a chain of the same block. And this is why it is called poly, because you have plenty, you have a lot of the same block.